Hello everyone, my name is Shreyas. I'm an educator at Unacademy, which is seen on my shirt over here. You can follow me on the Learning app as well, and you can see my new set of courses on the Learning app as well. So now I'm doing a lesson on 4-stroke engines. So previous lesson was 2-stroke engines, 4-stroke engines, which is actually very mobile and very much used in day-to-day life. All our bikes, everything, it contains 4-stroke engines. So let's go on to that lesson, and please do rate it, review it, and share it, and please do subscribe us. So guys, let's start with the course Elements of Mechanical Engineering. I have already given my introduction, so you can find me at the Unacademy user platform or the URL mentioned over here. So turbines, engines and pumps will be our course. Let's move on with it. So the target audience for this slide will be engineering students, general audience who are interested in mechanical entities, people who are interested in machine related mechanisms, and automobile enthusiasts. So the learning outcomes of this slide will be 4-stroke engines, 4-stroke petrol engines, working and operation of 4-stroke petrol engine, 4-stroke diesel engines, working and operation of 4-stroke diesel engine, as well as the comparison between 4-stroke and 2-stroke engines. So let's start with our lesson 4-stroke engines. Profit is the ignition system of our economic engine. So that's true, right? The code is very true, right, guys? So let's move on. 4-stroke engines, they are consist of 4 different strokes. Hence, the name is derived as 4-stroke engines. It works on diesel cycle, so that we all know, and it consists of 2 revolutions. That is nothing but 4 different strokes or 2 revolutions. You can make it actually the math. So it consists of the strokes, namely the suction stroke, compression stroke, power stroke, as well as the exhaust stroke. And in 4-stroke engine, this is what the 4-stroke engine is. So let's move on to the next thing. There is a 4-stroke petrol engine. Sorry, it was confusing there. So let's move on to our lesson, the 4-stroke petrol engine, or our topic. So a 4-stroke petrol engine, it works on Otto cycle, hence it is also called as Otto cycle engine. The charge used in a 4-stroke petrol engine is a mixture of air and petrol, which is supplied by the carburetor in suitable proportions. The charge is ignited by the spark generated. It is generated by the spark plug, and for this reason petrol engines are also called as spark ignition engines or SI engines. So this is what the PV diagram of this 4-stroke petrol engine is. So this is how the PV diagram goes. You can see the adiabatic constant volume process and all. That's actually a good PV diagram. It actually labels everything. So the suction stroke, let's start with it. At the beginning of the suction stroke, the piston is at top dead center and is about to move towards the bottom dead center. That is the reason I am written TDC to BDC. At this instance, the inlet valve is open and the exhaust valve is closed. The downward movement of the piston produces suction or a partial vacuum in the cylinder, due to which fresh charge of air and petrol mixture is drawn into the cylinder through the inlet valve. When the piston reaches the BDC, the suction stroke ends and the inlet valve is closed. The suction of air takes place at atmospheric pressure and is represented by the line AB on the PV diagram, which I will show in the PV diagram. And once the stroke is finished, the crankshaft, it rotates around 180 degree or half revolution of the full engine. The energy required for the piston movement is taken from a battery. So let's move on to the compression stroke. During the compression stroke, the piston moves from the BDC to the TDC. Both the inlet and exhaust valves remain closed. As the piston moves upwards, the air petrol mixture in the cylinder gets compressed, due to which the pressure and temperature of the mixture increases. The compression process is adiabatic in nature. And when the piston is about to reach the TDC, the spark plug initiates a spark or ignites a spark in the air petrol mixture. Combustion of fuel, it takes place at constant volume, and 4S petrol engines are also called as constant volume cycle engines. With this stroke, the crankshaft, it rotates by another 180 degree or half revolution, and the energy required for this piston movement is also taken from a battery. So let's move on to our power stroke. During the power stroke, both the valves are closed. As the combustion of fuel takes place, the burnt gases expand and exert a large force on the piston, causing it to move rapidly from the top dead center to the bottom dead center. The force or power, which is transmitted to the crankshaft through the connecting rod, is transmitted through the crankshaft to the connecting rod, and as a result the crankshaft rotates at very high speeds. The crankshaft then transmits the power through clutches, gears, chains and etc. So this is also, you can tell it as high transmission force or transmission of force. The expansion of forces is also adiabatic in nature and is seen here. Adiabatic expansion I have already written, and you can see the high speed rotation also. So the exhaust stroke, it is towards the end of the expansion stroke where the exhaust valve opens while the inlet valve remains closed. A part of the burnt gases due to their own expansion escapes out of the cylinder through the exhaust valve. This drop in pressure at constant volume inside the cylinder is shown out, constant volume. The exhaust stroke begins when the piston starts moving from the BDC to the TDC. The energy for this stroke is supplied by the means of a flywheel which it had absorbed in the previous stroke. As the piston moves upwards, it forces the remaining burnt gases to the atmosphere through the exhaust valve. The exhaust taking place at atmospheric pressure is shown by the line BA. And when the piston reaches the TDC, the exhaust valve closes and the working cycle is completed. In the next cycle, the piston starts moving again from the TDC to the BDC and the inlet valve opens, allowing fresh charge to enter into the cylinder, and the process continues. Thus, the 4 different strokes or one working cycle is completed when the crankshaft rotates 720 degree or 2 revolutions. So this is what I had told. So this is the suction stroke, this is the compression stroke, the power stroke and the exhaust stroke. So you can see how the inlet valve opens, exhaust valve closed, both are closed, both are open, and only the exhaust valve is closed. So you can see here the working model here actually. So you can see the spark plug over here, all the 4 strokes. So this is actually a 4-stroke petrol engine which is used in our labs. So let's move on with the 4-stroke diesel engine. A 4-stroke diesel engine, it works on diesel cycle. Hence it is also called as diesel cycle engine. The working principle is similar to that of 4-stroke petrol engine, except a fuel injector is used in the place of spark plug, and only air, it enters the cylinder during the suction stroke and gets compressed in the compression stroke. So this is the PV diagram for the 4-stroke diesel engine. So the suction stroke, at the beginning of the suction stroke, the piston is at the top dead center and is about to move towards the bottom dead center. At this instance, the inlet valve is open and the exhaust valve is closed. The downward movement of the piston produces suction or partial vacuum in the cylinder, due to which air from the atmosphere is drawn into the cylinder through the inlet valve. When the piston reaches the BDC, the suction stroke ends and the inlet valve is closed. The suction of air takes place at atmospheric pressure with this stroke, the crankshaft, it actually rotates 180 degree or half revolution. The energy required for the piston is taken from the battery. Compression stroke. During the compression stroke, the piston moves from the BDC to the TDC. Both the inlet and exhaust valves remain closed. As the piston moves upwards, the air in the cylinder gets compressed, due to which the pressure and temperature of the air increases. The compression process is adiabatic in nature, and when the piston is about to reach TDC, a metered oil of diesel oil is injected in form of spine phrase into the hot compressor air by fuel injector. The combustion of fuel takes place at constant pressure as shown there, and since combustion of fuel takes place at constant pressure, the 4-stroke diesel engine is also called as constant pressure cycle engines. With this stroke, the crankshaft rotates another 180 degree or half revolution. Power stroke. During this stroke, both the valves will remain closed. As the combustion of the fuel takes place, the burnt gases expand and exert a large force on the piston, causing it to move rapidly from the TDC to the BDC. The force or power is transmitted by the crankshaft to the connecting rod, and as a result, the crankshaft rotates at high speeds. The crankshaft it then transmits the power to clutches, gears, and other transmission elements to turn the wheels of the vehicle and cause it to move. The expansion of gases is adiabatic in nature, and since the actual work is also produced by the engine in the core, in this stroke, it is also called as power stroke or working stroke. So lastly, the exhaust stroke. Towards the end of the expansion stroke, the exhaust valve opens while the inlet valve remains closed. A part of the burnt gases due to their own expansion escapes out of the cylinder through the exhaust valve. This drop in pressure at constant volume inside the cycle is also to be noted. The exhaust stroke begins when the piston starts moving from the BDC to TDC. The energy for stroke is supplied by the flywheel, which it had absorbed in the previous stroke. As the piston moves upwards, it forces the remaining burnt gases to the atmosphere, to the exhaust valve. The exhaust taking place at atmospheric pressure is also seen. And when the piston reaches the TDC, the exhaust valve closes and the working cycle is completed. In the next cycle, the piston starts moving from TDC to BDC again, and the inlet valve opens. Only allows fresh air from the atmosphere to enter into the cylinder, and the process continues. Thus, 4 different strokes or 1 working cycle is completed when the crankshaft rotates 720 degrees or 2 revolutions. You can see here, this is actually the block diagram of a 4-stroke petrol engine, how it actually runs in the engine thing. So you can see the suction stroke, compression stroke, working stroke and exhaust stroke given over here. So this is actually the top side or the top view of the strokes or of the cylinders. You can see the carburetor also here. You can see the filter of the carburetor. So this is actually the 4-stroke diesel engine. You can see it's very big or enormous in size. So let's have a comparison of the 4-stroke engine as well as the 2-stroke engine. So the number of strokes per cycle is 4 as well as 2 here, and the number of revolutions of crank is 2 whereas it's 1 here, and the direction of rotation of the crankshaft is only in one direction, whereas it can be rotated either in clockwise or anti-clockwise direction. The power derived is in every alternate revolution of the crankshaft, whereas it is in every revolution of the crankshaft. The lubricating system, it has very separate lubricating system, whereas the lubricating oil is mixed with petrol. The torque fluctuations are very high in 4-stroke engine, whereas it is more uniform in 2-stroke engine. And the cooling and lubrication is very less required in 4-stroke engine, whereas it is severely required in 2-stroke engine. And coming to the next set of comparisons, that is the entry and exhaust of charge is through valves, whereas in 2-stroke engine it is through ports. And the thermal efficiency is higher, whereas it is lower in 2-stroke engine. The mechanical efficiency is lower, whereas it is high in 2-stroke engine. The suction of charge is due to the downward movement of the piston by creating pressure on the difference of the cylinder, and this is due to the pressure difference during the uncovering of the inlet port. The specific fuel consumption is very less, where it is very high in 2-stroke engines, and the exhaust of products of combustion is due to the upward movement of the piston, whereas here it is due to the scavenging. And the engine size is very heavy and bulky. 4-stroke, I have shown you guys the pictures also, whereas the 2-stroke is very small or more compact. So the fundamental terms are mean effective pressure, indicated power, brake power, friction power. Mechanical efficiency is the total efficiency of the engine. Thermal efficiency is the thermal efficiency of the engine. And specific fuel consumption, which is nothing but the amount of fuel consumed per unit area. Friction power is nothing but the amount of power lost in friction, and the brake power is nothing but the power developed by the engine at the output shaft, as well as the indicated power is the power developed inside the engine cylinder. So thank you guys. Any questions, please drop those in the comment box below. You can follow